Hi, this is Thorsten Reiners from Curtin University, Perth in Australia, and I'm the presenter for the paper on mobile application to create interactive learning environments in 3D environments. This is a collaborative work with Lincoln Wood, who is currently in New Zealand at the Auckland University of Technology, and Theo Bastian, who is in Germany at the Friend University at Hagen. In this chapter, or in this paper, we kind of interested in how we can bridge a gap that currently exists between the bots, virtual intelligent avatars controlled by computers, and the user who should, first of all, interact with these bots, but also use bots to live their 3D space. We had several ideas in different projects how to improve this interconnectivity, but finally found out that we should look in how we actually connect the real world with the virtual world currently in other disciplines. And if we look at the social web or social networks, the mobile device is one mean of technology that is used to be online at all times, being connected to the social networks in both ways. The one way is to monitor online activities. We get notification on our mobile device if something changed in our community. We don't have to open all the different applications. We just get a report of who posted something, who changed the status, who actually wants to get in contact with us. On the other side, the mobile device and the apps on it take some of the work away from us about reporting back to the social network. That is, we are not necessarily have to report our location and how often we are at a location. That is done by Foursquare. When we shop something, we can inform a certain group of people about that, Shopify. We also can report that we played a game and got some skill experiences or have a new high score if we communicate with our OpenFaint network. So the mobile device became the real-world mediator with the virtuality with our social networks. We have a similar thing that we use websites or the web itself. If we are logging into Google, we report to other people that we're online. They see a little dot. We kind of report that we are on Facebook by actually having a little dot next to our name again. The Dropbox is telling other people that are connected to the same device that we upload or changed a file. We have websites that use little avatars to demonstrate that we are currently looking at a website, that we have that website open in our browser. Yet, we don't use these technologies to actually have the same in virtual worlds. In virtual worlds, we most of the time feel alone. We feel alone because no one is there. It's empty. Even this replica of Athene is missing the life. It is missing bots. It's missing avatars from other users. It's missing something when we get there. Now, just focus a little bit on any city you want. It's not necessarily important that you know the people that walk around. It's more kind of a background noise of other tourist shop owners that produce some noise visually as well as audio. And this noise is quite important for us. We get that on social networks. We get a constant update of our certain activities. Even in OpenFaint, we get scores from other people all the time. So we're getting a background noise, don't feel alone anymore. And as I mentioned before, we kind of miss that in a virtual world, and we think that one solution to improve that are actually mobile devices taking over the responsibility of updating, of connecting, of changing, of reporting and monitoring for virtual device. So basically, just quickly, in virtual worlds, we use the definition by Gregory presented on the Escalade in the name of the Virtual World Working Group, which means that which says that virtual worlds are computer-based, immersive 3D multi-user environments that simulate real or imaginary life experience through a graphical representation of the user, which is the avatar. The immersion is something that kind of like overloads our sensory perception by other means. So rather than seeing the real world, we see the virtual world. The eyes get a different picture. Ears can hear different sounds from this virtual world. We even can have haptic feedback via virtual gloves. So there is an overload of our sensors. On the other side, we also interact. All our movements can be transferred back to the virtual world through keyboards or other devices. The advantage of virtual worlds, especially for education, is that it takes the distance out of distance education. We can come together in the same room, the same classroom, the same facility, or kind of like a manufacturing place, to demonstrate to students certain processes. We can do that at one time with all students being at the same place at the same time. And it's safe. If we go on a field trip, we have to worry that someone could be injured if, for example, run over by one of the vehicles on a container terminal. In virtual worlds, this can't be happening. The only problem is, as I mentioned before, the lack of a sense of being alive. Kind of you feel alone. So we want to improve on that by using certain technology that records the real world and transfers it to the virtual worlds, but also merging virtual and real world display by having kind of like a more immersive visualization. For example, the head-mounted displays are currently one way of actually increasing the feeling of being really there. Bots are kind of like the representing users, but are controlled by a computer. It allows a 24/7 learning support. We can't expect that a teacher or lecturer or any person is there for 24 hours, or even having different shifts because of the cost. So when I come there, I want to have support. It could be a bot that is programmed to react on me and actually demonstrates an exhibition, or how a machine is working, or how I have to prepare for a certain lecture. It gives you guidance, and the bot can also monitor you. If you do a mistake, it actually interferes. Their current limitation, they are too complex. It's really too hard to integrate them and to program them. Not all the functionality that we require is existence, and there are basically no real interfaces with the virtual worlds, especially Second Life is quite limited, and lack of knowledge to program or to use them. Good place to learn is actually from the gaming industry. If you look at the modern games, they have real intelligent and non-player characters, which are nothing else but bots. We use an example, and I just want to quickly give you an idea about it, where we want to integrate the bots. We had another project, Virtual Prax, that looked at preschool teachers in a classroom where we had bots for the students, and also had a look on some parts on a container terminal where bots were driving the vehicle. We want to have an authentic simulation of a warehouse in Second Life, where we have a guided monitor learning. Still, the student is free to explore the space without any instruction. He has to figure out how things are working and is getting more or less feedback to improve on the next one. So it's an indirect support by feedback as well as by the environment, because we will have bots, as I show you in a second. The idea is you have a warehouse, you have the shelves, you have forklifters, you have a computer where you get orders, and you have a warehouse gate where you actually deliver the order, so a box or something. An idle case would look like that, and it's like kind of the path that we expect the student to take from the start on the right, looking up the order, picking up a right forklifter, goes to the shelf, picks the order, and brings it out to the ute. That's an idle case. That would an expert do. A student new to the scenario might end up like that. Don't want to go through the whole path, that would quite take long. But if you start with the avatar, and I challenge you to follow the lines, the student here walks right out on the right, on the left, to the ute, and has not the order ready or anything. So we have a bot waiting there, a bot that is triggered by anyone coming out and verifying if that one leaving the warehouse is having the order ready. If not, the bot would go over and mentioning that they're already waiting for a certain time. They don't give hints how to do the job, but telling you what the final outcome will be. So the student can take that hint, go back and figure out, okay, he needs an order. He didn't tell me which one, so I have to go to a computer terminal and look it up. Going out again without an order, the driver would probably tell more details about the order, like what kind of order it is, when it was ordered, what the name maybe is, something the student didn't ask. So, just like one example for a bot. The disadvantage is bots are not easy to observe. So we have this self-guided learning environment. Anyone can go in for 24/7. So we need to have a possibility to get a report, but also have a chance to interact directly. We use mobile devices as this window, and despite the fact there are certain applications, we couldn't find one that is actually doing everything. Looking at the objects, looking at the users, looking at the interactive bots that we implemented there, and is allowing for complex scripting. So we decided to develop our own using interest-based application. Android, as it's reusable. We have a large availability of devices. It's a kind of a natural interaction with touch and all the acceleration sensors. The development offers a good simulator, which was quite important for us to simulate different devices, and there's also everything free to do the development. We come up with a small framework, and I rather suggest that you are looking into the paper for further details. Just quickly, the mobile device is communicating directly with the virtual world, for example, Second Life, by registering and then exchanging multiple messages using the UDP protocol. So a message is sent, and I get the mobile device get feedback. Based on the feedback, it decides to send another message, gets another message back, and so on. So that is a technical loop. On the other side, we have the server as a mediator. So the server could be on the mobile device, and that's actually good to have if you are connecting directly with a virtual world. On the other side, you want to have like a link between multiple users being in the environment at the same time. The server has a user database taking notes about all information and attributes of the avatars of the user. An object database, all the objects that are in the virtual world, including with the attributes. What can you do with an object? And the bots itself, including all the kind of like possible interaction features, what triggers the bots, how should a bot interact with that. There's an AI module connected to the bots, so we assume a certain general knowledge, but this AI obviously has to be adapted for certain scenarios. Specific knowledge, domain knowledge. We have a scenario module, which kind of gives an initial state about the environment, and the bot defines what triggers are to activate bots, messages that are relevant in the communication terminology and things like that. So basically an action is interpreted, updates the database, and sends a comment to a certain virtual world. The translate means that we actually adapt, kind of like have the generalized server, but translate then this comment in the language of the virtual world. On the other side, we have the same back. Messages are kind of like directed through the server, interpreted, kind of like stored in and or merged with the information in the databases, and then update the mobile device. Again, for more details, I would recommend to have a look at the paper and check out for yourself. The only thing that I kind of want to present in the talk and get you kind of like interested in following up our developments are the interface and two examples for the communication. The interface has different parts, and it's kind of like a prototype. We needed like kind of the typical chat, seeing what's going on in chat, navigation, so you can actually navigate the avatar. We didn't want to do the 3D view on the mobile devices. We, on purpose, disconnected the 2D display of the mobile devices with the 3D of the virtual world. This is more for sending commands rather than actually using the mobile virtual world. So you can navigate, you can walk forward, and you can see it on the top right on the map where you are, so you can change the avatar or user, kind of move around. We have visibility of all objects that are nearby, and you can actually give comments, so your bot that you're currently controlling can enter a forklift, enter in terms of getting on, sit down, or actually drive it. There are more comments, like when you have that, you could give a destination where our bot should drive to. You have another map. You have multiple maps that you can choose from. So simple interface, simple interaction, but what's most important is it's recording everything and replaying. And you can follow top right one, the green dot is the learner. You can follow what the learner is doing if he reached certain milestones in your script. And the other one is like just an example for the communication. So when you have the app, you kind of like send a command to retrieve all objects to get a list of objects back, or kind of all objects that are existing. And based on that capabilities that the objects have, you kind of trigger certain things, like trigger forklift 1, sit on the seat, means that the bot should sit on a seat in the forklift 1. You get updates and you can send other comments, so it goes back and forth. On the other side, so that is like more communication path. On the other side, you have triggers. You define triggers beforehand, could be a proximity or entering certain areas or doing certain commands, saying certain sentences. In this case, the avatar enters the bot 1 area. So you have the U driver, use the example from before, and the avatars getting closer, which means that the user avatar, the U driver, sends a message like a hello, just friendly greeting, sends a list of capabilities, which kind of like possible to do. Like you can say something back, you can shake hands, you can leave objects. In this case, the avatar requests an object and the U driver would pass it, which is one possibility. Which could be request an object, could be the documentation for the order that the U driver passes over to the avatar. So just a quiet little window into this presentation, and I wanted to put the focus on the bots. I wanted to put the focus on the bot as an important part of and live in the virtual worlds. I wanted to use, I mentioned that we need a device to communicate with the bots. We can log in and play with them, we can use simple interfaces, but we are not having the same kind of communication that we currently achieve in social networks and in our navigation on the web. So there is this gap that we want to overcome, and we believe that the mobile devices, in a more complex way than they are currently used in the connection between real world and mobile devices, can bridge this gap and make bots an actually important feature of interacting with virtual world and a very important tool for educators in connection with their learning. Have a look at the paper. There's everything presented in more details. I thank you for your attention and listening to this presentation. And please keep contact us if you have further interest to follow up or want to participate in our research. Thank you very much.